So in the previous video, we went from the initial integral x cubed plus 1 over x times the quantity x squared plus 1 squared dx. We used the method of partial fraction decomposition to first break this down into three integrals, and then we used some algebraic techniques to further break this down into 5 integrals that are now a little bit easier to find antiderivatives for. So again, I say a little bit easier. Some of them are more trivial than others. So what I'm going to do in this video is start to go through the integration of each one of those 5 integrals, and then we'll put them all together in the end. And as I said, probably the easiest of all of these is going to be the first one, integral dx over x. That's the natural log of absolute value of x plus c. Next, we have negative integral 2x plus 1 over the quantity x squared plus x plus 1 squared dx. And for this, we're going to use a u substitution with u equal to x squared plus x plus 1. And du then would be 2x plus 1 dx. And now we can put this integral together in terms of u now, and that would be negative integral u to the negative second du. And this is not a natural log, but it's going to turn out to be positive 1 over u plus c. And so just make sure that you understand how that all came about there. So now we have our second integral. I think that ln got erased somehow. So we'll go on, we'll skip over the third integral, which is going to be a little bit more time consuming, and we will go on to the fourth integral. And for this fourth integral, what we're going to need to do is to do again a u substitution, as we did with integral number 2, and we'll see how that works. U is going to be x squared plus x plus 1, and du is 2x plus 1 dx, so giving us in terms of u negative 1/2 integral du over u, and that's going to give us negative 1/2 natural log absolute value of x squared plus x plus 1, and then plus c. So that's going to do it for the fourth integral. And I think we have room enough to work with the fifth integral, which is positive 1/2 integral dx over x squared plus x plus 1. And what we're going to need to do with this one, we're heading in the direction of the inverse tangent on this particular integral. And so what we're going to need to do is to complete a square in the denominator. And again, you may want to stop and work through that and make sure you understand how the completion of that square worked. It didn't come out with nice, easy numbers, but still it's workable. So I'm going to suggest that you use a formula, and that formula is that the integral of 1 over u squared plus a squared du is equal to 1 over a inverse tangent of u over a plus c. Now that's a cousin of the basic variety of the inverse tangent, which looks like that. Now we could do a u substitution with this on our own, but it's a fairly involved process, and you may want to work through that just to convince yourself that it actually does work out. But what we're going to use here is u is x plus 1/2, and then a has to be the square root of 3 over 4, which is root 3 over 2. And I'm going to give, as I've run out of space on this page, I'm going to give the simplified version of this antiderivative. And if you need to, pause the video, work through it yourself, and make sure you can come to the same algebraic destination. And that is square root of 3 over 3, inverse tangent of 2x plus 1 over the square root of 3, then plus c. Again, all you needed to know was that u is x plus 1/2, and a is root 3 over 2. And then when you plug all those in there with the 1/2 out front and you do the simplification of the algebra, or do some simplification of the algebra, then you should end up with something that is equivalent to what you see there. Root 3 over 3, inverse tangent of 2x plus 1 over the square root of 3 plus c. And that brings us down to just the final integral, which would be integral number 3. And for that one, I'm going to skip ahead to the next page. So if you need to work through any of this, pause the video and work through it until you're comfortable with each of the steps there. You may need to practice these steps multiple times in order to become very fluent in what's happening in them. But they are very important steps, and this is an all-inclusive problem that has so many different aspects of calculus integration involved in it. Okay then, so our final integral that we need to work with is negative integral dx over x squared plus x plus 1 quantity squared. Now we're also going to need to complete the square with this particular problem as well. And when we do, we should end up with something like this, which is very similar, which is exactly what we had in the integral number 5, except that here the entire denominator is then squared. So now I'm not sure if there is a formula that's going to allow me to do this quicker. There very well may be. I'm not familiar with it. But at least what this will do is I will go through the process of how we could do the transformation of this expression so that we can get it into the form that we need to do a trig substitution with. All right, and so I'll take you through that step by step here. And the first thing that we want to do is we want to change that 3/4 into a 1. So I'm going to need to factor out a 3/4 from the whole denominator. Now I know that's really sloppy there. Well, not that it's sloppy, but it is very involved there. So what we're going to do, remember that the whole thing is squared. That's our outermost parentheses. Then inside that we are multiplying everything in the square brackets by 3/4. So we need the 4/3 in front of the x plus 1/2 quantity squared to so that when we multiply by 3/4 we're going to get 1 there. Then we're going to distribute the 3/4 to the 1 as well. Now the next thing that I would do here is then to because the 3/4 is a factor of that whole squared expression, I can bring it out of the square, bring it all the way out of the integral, and that would come out as, since it's squared, as 9/16 in the denominator, 1 over 9/16. When I bring it out and take the reciprocal or the reciprocal, whatever, that's going to come out as -16 over 9. But by bringing that out, it does make our integral just a little bit simpler there, easier to work with. And again, you can pause at any point and make sure you can work through the algebra involved there. I'm not going to go through that step by step. It's a bit of a leap, but it's not too bad. The next thing that I want to do then is I want to bring that 4/3 inside of that squared expression there. And since I'm bringing it inside the squared expression, I'm going to take the square root of that. And so I would get something like this. It's going to look something like that, 2 over square root of 3x plus 1 over square root of 3x. Then I can combine those two fractions inside the squared, in the squared expression, since they both have a common denominator. I'll do that in the next step. And that actually is an expression now that we saw in integral number 5, I believe. Now the next thing that we're going to do with this is a u substitution with u equals 2x plus 1 over the square root of 3. But in an effort to keep these videos at under 10 minutes each, I'm going to stop this video at this point and continue in the next.